welcome everyone, and thank you very much for coming to my talk. It's the last one. I know you're all tired, learned a lot of interesting things, so hopefully mine is going to be a good end for a really exciting day. My name is Justina. I work at Rasa, which is a Berlin-based startup, which is working on open source software for conversational AI. I have a background in econometrics. I worked as a data scientist for a couple of years, and then I just fell in love with open source projects and conversational AI more specifically, and I joined Rasa, and now I work on developer education and building Rasa open source community. So yeah, it's all exciting. So I'm going to talk about how you can build AI assistants that scale using machine learning, and also assistants that can go beyond, sorry, I didn't get that. And before I dive into all the content I have ready, I'm going to do all specifics that need to be covered. So my goal today is to show you how you can build your own machine learning powered assistant using open source tools only. The roadmap for my workshop is going to be that I'm going to explain you a lot, step by step, how development of an AI assistant looks like and everything that is under the hood when it comes to open source tools that I'm going to use. And also every single part will include coding. At the very end, I will leave some time for questions, but if you have some burning questions throughout the talk, just raise your hand. I'm happy to answer any questions you have. And the setup, so there are quite a few ways how you can follow this workshop. One of them is to use a Jupyter Notebook. That's what I'm going to use. And you can get them by following this link at the top. There are actually 3 Jupyter Notebooks. I will explain which one I would recommend you to use and so on once we get to the actual point of coding. But if you don't want to use Jupyter Notebooks on your local machine, or something doesn't work, you can use Google Colab as well. So all these links are also on PyData proposal of my talk, so please go check it out and get them ready before we dive into the coding part. Great, so I'm going to talk about conversational AI, and I think it's really hard to surprise people with chatbots and conversational AI these days, because probably every single one of you already saw a chatbot or used one. But despite of all this hype and a lot of attention from the industry and from the research, it's still quite an early stage for this field. And developers that are building assistants, they still use quite limiting approaches, which are rule-based approaches or state machines for building assistants. And they forget a few very important things what make an assistant good and intelligent. So one of them is that AI assistant must be able to generalize well on different user inputs and different users as well, because there are so many different ways how one person can say something that has the same meaning but using different words, vocabulary, structure of the sentences. So a good assistant must be able to generalize on different types of speech. And also another important piece about AI assistants is that they must be able to learn from additional information that a user provides, or even better, learn from its own mistakes. So just like in this visualization here, you can see that if a user provides some additional details or corrects the assistant, an assistant must be able to pick up those details and learn. So these are just a few challenges that Rasa is trying to tackle, and as a result, Rasa developed an open source software stack called Rasa Stack, and it consists of 2 Python libraries. First one is called Rasa NLU, which is just like the name suggests, is library for natural language understanding, so enabling your assistant to understand what is the user's input and extracting important information. That helps an assistant to make more specific answers and correct answers. And another piece is called Rasa Core, which is a machine learning driven dialogue management system, which uses machine learning and real conversational data to predict how an assistant should respond based on the state of the conversation and also the context. And those answers, they can be a lot of different things. They can be simple text responses or voice responses, or it can be something more complicated, like some kind of backend integrations like API calls or getting data from the database. So basically, the sky's the limit of what you can do. So how an assistant looks like that is built with Rasa Core and Rasa NLU is here. It's a simplified architecture. So let's say we have a user who asks, what's the weather like tomorrow? And the first stage that this message would go through is a connector module. So this is where you can use any voice or messaging platform that you prefer. Can be, I don't know, Facebook Messenger, Slack, Telegram, or your own inbuilt, custom-built UI for your chatbot. Then once this message is picked up, it's sent to input module, so-called ears, and this is where Rasa NLU model stands, and it crunches the input of the user and extracts the meaning of the user input as well as all the details that are important for an assistant to respond well, and they are passed to dialogue management, so-called brain. And this is where Rasa Core model stands. It takes all the details from NLU model and previous conversations, and it predicts what response or what action should be executed at specific state of the conversation. And as I mentioned, you can use backend integrations there. And then once an assistant has all the details to make a response, they are all sent to output module, so-called mouth, which is responsible to generate a response in a regular human language so that a human could understand and do something with this information. Here you have a bunch of options what you can do. You can use NLG, natural language generation approaches, or you can use UI elements, buttons for example, or you can use a very simple approach, just simply provide some possible responses how an assistant could respond based on the details that it extracted. And then once the response is generated, it is sent back to the connector module, so that's how a user gets the response. So for example, it will be sunny and 20 degrees to the previous question. So why Rasa? I think you probably know some alternatives to that, which are hosted solutions. For example, you probably heard of Dialogflow, Luis, Vid.ai. Few things. So one of them is that it runs locally. It's really up to you where you want to run your assistant. You can run it on your local machine. You can run it on the cloud. You can run it on your custom server. You just take it and use it wherever you want. Another thing is that you own your data, and that's super important for companies that work with sensitive data. So it's open source, so your data and conversations that users have with your assistant never gets to Rasa. We don't see what is happening and what kind of conversations your users have. So you own your data and you are in charge. Who can see it, who can use it, who can access it. The biggest advantage of open source is that it's hackable, and there are really no black boxes. You can see everything. You can see all the code, all the models. You can tune the models. You can add your own custom components, replace models if you are not happy with the ones that are inbuilt for Rasa. So it's really a lot of fun that you can have as a developer with this framework. These are the main advantages for using Rasa for your projects. So now, at this point, I will go deeper into these two components, Rasa NLU and Rasa Core, and explain what is happening, where is machine learning hidden, and how it works, and what kind of models are being used. So I will start with the first stage of AI assistant development, which is natural language understanding. So the main idea, as I have mentioned, is to enable an assistant to understand what the user means, what they are asking. So the goal is to take unstructured user input in a simple human language. For example, just like I have an example here, I have a new address, it's 709 King Street, San Francisco, and probably user wants to change an address to this new address. So the goal is to extract structured details from this input, which an assistant can understand and use in the later stages. The structured data consists of two components. First one is called intent, so overall intention of user input, what it is about. So for example, for this specific example, a good intent label could be address change. And another component of the structured data that is extracted is called entity, or it can be a bunch of entities, which are pieces of information that are necessary for an assistant to extract and understand and use to make correct responses. So for example here, an address, 709 King Street, San Francisco, is a good example of an entity. It's something that an assistant should extract and then use to make an actual address change. So how it works, the main idea is that we use word vectors. So hopefully you know what word vectors are. And also an important thing here as well is that it's just one of the ways of how we can do it. So if you have a new user input, for example, what's the weather like tomorrow, the overall process is that it goes through vectorization stage. We look up word vectors for words and create sentence representation, which is used to build a classifier. And this classifier gives output in a following format where you get the label of the intent, like what was the intention of user input. More specifically, bag of words are your best friends here. So let's say you have a new user input, what's the weather like tomorrow? The first stage that this input goes through is tokenization. So a token can be a word of a sentence, and then for each word, the model would look up a word vector. Here you also have a choice of glove vectors or fast text is also a good choice for pre-trained word vectors if you want to use them. And then the next stage is creating the sentence representation. Here you can see we take the average. It's really simple. It surprisingly works really well. It's being used to train the classifier. In this case, it's a support vector machine, pretty simple classifier that gives the results in a following way. So if you have in your training data 5, for example, possible intents that you wanted your assistant to understand, the result of SVM will be one of those labels. That is the most probable that the model thinks. Then the next stage, entity extraction, is quite similar process, but there are just a few additional steps. So it's all based on vectors. So whenever there is a new user input, again, the sentence is tokenized into words. Also, you can use a part of speech tagger and use that as a feature for the model. So you would use grammatical meaning of the word. Is it a verb, adjective, noun, and stuff like that. Another feature that can be added to the model are chunks. So chunker creates, just like the name suggests, chunks of words from a sentence. And why it's useful, because some entities, for example addresses, it consists of more than one word. It's usually at least 3 or 4 or even more words in a sentence. So it's important to build models that can extract 1-word entities, 2-word entities, and so on. And this is where chunker comes in to help out. And then these and other features are being used to create a named entity recognition model, and the result of this model is as follows. So you would have the label of the entity as well as the value of the entity. So for example, in this specific example about the weather, the entity is date, and the value of the entity is tomorrow. In other user inputs, for example, if a user asked what's the weather like today, the entity would be date again, but the value would be today. So how that works, there are a few approaches for this problem. One of them, you can build one classifier to first classify if there is an entity in a sentence or not in the first place, and then use another classifier to predict the label of this entity, but it's time-consuming and also quite resource-heavy. So the way it works at Rasa is called direct structured prediction. So basically those two problems are tackled at once. And the algorithm that is being used at Rasa here is called conditional random fields. So it works in a very similar way as a skipgram model, which uses surrounding words in a sentence to predict the label of the target word. So using pre-trained word vectors works really well, especially if you have limited amount of data. And why it helps, because by using pre-trained word vectors, you don't need to learn word embeddings yourself, and also because it allows your model to learn semantic meaning of the words and relationships between the words. But it also brings some limitations. So using a classifier type of approach, you are only able to assign one label for user input, as in what is the intent of the user input. However, well, we as humans are complicated, and our speech is not that simple, and things are not that easy. And so many times when you speak to your friends, when you send your friends a message, you usually express more than one meaning in a sentence, or more than one request or questions in one sentence. So if you want to build assistants that can handle natural conversations, it's important to tackle those type of challenges as well. And this is where Rasa did a lot of research in the past few months, and built a new model called TensorFlow embedding model, which is capable of doing what you see in an example here. When a user's input has more than one possible meaning, the model is able to assign 2 intents or 3 intents for the same input, and that makes the conversations more natural, and the flow of the conversations a lot more human-like. So how it works, first of all, the problem is called supervised word vectors, which means that the model learns word embeddings from scratch. So basically using the data that you provide that you have in your training data set. And this model is inspired by a paper called Star Space, which is a paper from Facebook Research. They're doing a really amazing job on that end. And so if you're interested to learn more details, definitely read the paper. I will share my slides after the talk, so you will also get all the links as well. But the main idea of this model is that instead of having a classifier that assigns a label to the user input, it's a ranking method. So you have user input, you have the intents, and you learn embeddings for both. And then the process is that you calculate the similarity between user input, the sentence, and all of the intents. Here you can use, for example, cosine similarity, and then it's the matter of optimizing the loss function and getting the most probable intents based on the ranking method. Yep.
Is that the same pre-trained embedding layer for each? Like just taken from like Wikipedia or something like that?
No, so here you don't use any pre-trained word vectors. Again, it learns from the data that you provide in your training data set. I will show you how the data looks like, but you don't use any word vectors out there from Wikipedia or anything else. Cool, and actually that's a good time to, to dive into some code and show you how things work. What I'm going to use, and so I told you about all the possible ways to follow this workshop. I'm going to use Jupyter Notebook, but again, it's up to you which one you prefer using. And if you are using Jupyter as well, you probably saw that in the repository that I shared, there are 3 Jupyter Notebooks, so I'm kind of ready for all possible outcomes of this workshop. I'm a bit jet-lagged and had too much coffee, so who knows what can happen. So basically, I'm going to use Rasa PyData DC workshop starter, which means that some of the bits in this Jupyter Notebook are going to be left out. So I'm going to do things here live. But if you want to see all the code completed and all the outputs, you can either choose workshop executed, which has all the cells completed and all the results printed out, or you can use workshop completed, which just basically has all the code. So it's up to you which one you choose. And also there are some other files here. Some of them are just simply outputs of some of the cells in a Jupyter. I'm actually going to use 2 of these files. One of them is called stories.md, another one is called nlu.md, but I will show you where. It just basically to cut some time in this workshop. So I'm going to use, again, PyData Workshop Starter, so if anyone is following me, do give it a try. Great, so in this exercise, I'm going to show you how to build an assistant, quite simple, but hopefully fun for you, from scratch. And the main idea of this assistant is that it's going to be a chatbot that is going to be able to suggest interesting research papers for people to read. So, for example, if you ask, I want to read a paper about, I don't know, statistics or something like that, an assistant will be able to give suggestions and then handle some follow-up questions. So simple, but it's just to show you how it all works. So it's going to be, again, in parts. I will cover this step by step. And the first part that I'm going to start with is some configuration. So it's not really Rasa related, but I'm going to use logging to see where things go wrong and to debug my code easier if I make typos, which might happen. Also, I am turning off some of the warnings because some libraries, for example, sklearn is throwing way too many warnings sometimes, so I just wanted to keep things clean. And this little pretty print function, again, is not really Rasa related, but it's just going to print out JSON output in a nice format for us to see the results easier. Okay, so the next step is actually installation. So for this workshop, I'm going to use only basically 3 libraries: Rasa Core, Rasa NLU, and sklearn CRF suite. I'm using specific versions of Rasa Core and NLU because it's still kind of under development, and new features are being added to Rasa Core specifically quite often. So I just wanted to make sure that everything works for everyone. And before I move on, I will just check if that's actually what I wanted to get. Yeah, so I wanted Rasa NLU 13.6 and Core 11.11. That's exactly what I have. Okay, and another thing which I know already caused people some issues is GraphViz. It's a quite stubborn library to use, especially if you are a Windows user. So I know that some people also have to make some changes to their environmental variables or path on their system to make this work. So if you get errors at this stage, just please don't feel frustrated. It's not mandatory, again, for Rasa, but it just helps to visualize data in a nice way. So if you get errors, just just skip the step, and I will show you the output as it should look like. Okay, so now let's actually get to the NLU part. So since it's based on machine learning, the first stage where you should start your chatbot development when you use Rasa NLU is conversational data. Now, it's actually one of the trickiest parts when it comes to chatbot development because conversational data is really hard to find, and it's not something that you would probably find on the web, especially when it comes to research paper search. You probably wouldn't find those type of dialogues anywhere. So there are few suggestions that I would give you how to get started. If you cannot find any data anywhere or any clues how the conversations could go. So one way is to play a little game and pretend that you are a bot yourself, and just ask your friends or colleagues to ask you questions and just try answering them as you were a bot. write down those conversations and then use them as the basis for your models. Simple and quite fun way, but it actually is quite a good starting point. Another one is called interactive learning in Rasa core. I will show you at the end of the workshop how it works, but it's also one of the good ways to start generating some training data. But I used the first approach before this workshop, and I actually wrote down some conversations myself. So I have 2 possible conversations here. As you can see, the conversation would start with hello, and assistant would ask how can it help, and then a user could ask for papers about mathematics or anything else, and an assistant would actually go and look for a paper to suggest, and then everyone is happy. Another possible conversation when a user asks for research paper but don't tell exactly what type of paper they're interested in, so an assistant asks for this detail to make the search more specific. And then also a user asks for some follow-up questions. So, for example, who are the authors of the paper, and so on. So if you also start your own assistant in your own specific field from scratch, the goal is to gather some conversations that cover different turns of the dialogue. Because again, it's machine learning, so the data has to generalize, help your model to generalize well. So the one thing that you have to do once you have some conversational data is to convert it into the Rasa format. And this Rasa format for NLU data consists of labels of the intents that you would like your assistant to understand, and possible examples of how a user would say those specific things. So I'm just going to show you a quick example of how this data would look like. And I will use this conversation number 2 to actually go through the conversation line by line, and I'm going to convert it into the Rasa format. So the conversation started with the user saying hi. So the overall intention of this input is greeting. A user says hi. So here I'm going to create a new intent, and I have to provide the label of this intent, so it's going to be greet in this example, and then I will just going to provide the actual example how the user will say that. So it was hi. Chatbot responded, hey, I'm a paper search assistant, and then a user said, I'm looking for interesting papers to read. So it's not greeting, it's something else. This is a paper search, so that's why I would create a new intent, which I will call paper search. And again, simply the example goes in. I am looking for interesting papers to read. An assistant asked what type of papers are you looking for, and the user said about physics. Now, this is not greeting, and it's not really a paper search because it's just user providing some additional information. So it can't really go into greet intent, it can't really go to paper search intent, so I'm going to create a new intent again, which I will call inform, because it's just providing some additional information. And I will provide the example, which I can type. Now, important thing here is that we also have to label entities so that the model would learn to extract those as well, not only intents. So physics is a good type of entity in my case, because it's the type of paper and it's an important and useful detail that will help an assistant to make more specific search, API call, a little disclaimer, to actually suggest something in a physics field. So to label entities, what I have to do is I have to add square brackets around the actual value of the entity, and then in the parentheses type in the label of this entity. So since it's paper type, I will just call it that way, paper type.
Could you scroll it up so we can see it?
Oh, yeah, sorry. So then an assistant would go and look for a paper, and then asked if a user would like to get a link to the specific paper, and the user said, sure, can you also tell me who are the authors of this paper? Now, this is a tricky one because, as you probably see, there are those two intentions and one input. User wants to get a link to the paper, but they also want to get the list of the authors who wrote the paper. So again, we can't really put this into any of the intents we have already. So I'm going to go ahead and create a new intent. And here, since this is a compound user input, I will have to write down the label of the intent that consists of tokens of those multi-intents. So one meaning of this user input, sure, can you also tell me who are the authors of this paper, is just confirming that a user wants to get a link, or affirming that a user wants to get a link. So that's I'm going to type in. This is the first meaning of the user input. And another one is asking about the authors of the paper. So that's why I will add plus and write down the label of the second token of user input, which I will call authors. So that means that this user input will have two meanings, affirming and also asking who are the authors of the paper. And then again, just like with every other example here, I would just simply provide the example. If in other case a user would just say, I think I actually have an example in a previous conversation, when an assistant suggests, hey, I can send you a link if you would like to get one, a user said, yes, please, then this type of intent would not be able to be added here because it's not a multi-intent. You would have to create a new intent called affirm, but both of these, I can actually do that. Intent affirm would be something like, yes, please. And then when the model trains, this intent would be used to train the token affirm, as well as this one would be used to train the token affirm, and that's how the model would know when to use two labels for user input, when to use one, and so on. Yeah, and then user said thanks, so that would be another intent, for example, called thanks, since it's thanks. Oh, thanks. Yeah, and then you would just simply, and then you simply would provide the possible ways of saying thanks and so on. So that's how it looks like, but again, this is just a very tiny example of training data, way too small to actually build something that would work. So you would need at least, I would say, for a simple chatbot that is capable of handling 1 or 2 actions, I would suggest having at least, I don't know, 5 to 10 possible ways of how a user could say greet, how a user could look for papers, and so on. And this is where I'm going to use one of those files that I mentioned that I have in my repo, which is going to be a little cheat, and it's an example file of more training examples. I'm going to put them in here. You can do so as well if you're following me. So basically, again, just as I said, it's just a little bit more possible ways of how to say goodbye, of how to say hi, of how to affirm, and so on.
If you have a long string, does it look at parts of that string, or does it have to match the entire length for can you tell me who are the authors of the paper? Does it just look for author's paper?
No, it's not. Again, it's not really regex. It's not really matching. It uses features that I extracted from text. So those features can be engrams of words. It can be or surrounding words if it's about entities. So yeah, it's not matching at all. And again, another important thing is that you don't have to write all the possible ways of how to say no or how to say hello or something like that, because again, it's machine learning. So with enough examples, the model will start to generalize, and it will learn how to classify user inputs correctly and how to extract entities as well. So again, you don't have to write all the possible papers that you can read out there. That's the main idea behind machine learning, that you don't have to cover everything, but a little bit for a model to learn. So I'm running this cell here just to simply save this data file that I now created. And then once you have training data, which is the biggest and the most important part of every machine learning problem, you can actually go ahead and define the model. And in Rasa NLU, you can define the model by creating the configuration of the pipeline. And the pipeline simply defines how features are going to be extracted from those examples that you have in your training data, also what models are going to be used, and so on. So if you are not familiar with machine learning for NLP and you are now thinking like, oh, it's too much to understand, there are some pre-built pipelines that doesn't require you to know everything and understand everything that is going under the hood. But if you are, you can again have a lot of fun with customizing pipeline and adding new components or removing. So the one that I'm using today here is one of them is a tokenizer. So how the sentences are going to be parsed into words. Here I'm going to use simply a white space. So whenever there is a white space between the words, the model will know that it's the word, that it's a new word, or that the word ended. This NumFOCUS defines the conditional random field model that I mentioned previously is going to be used for entity extraction. Then this one, which is called classifier TensorFlow embedding. So this is a classifier for intent, so the one TensorFlow embedding model that I mentioned previously that doesn't use any pre-trained word vectors. And since we are having some multi-intents, it's important to tell that to our model. So by setting intent tokenization flag to true, I'm letting my model know that whenever it sees an example like this one here, affirm plus authors, that means that there are actually two tokens for this entity and that they should be separated and trained. Each of those tokens should be trained, and also you have to specify what symbol, what character was used to when creating those multi-intents. So since I used a plus, I'm using a plus here. If you used, I don't know, hyphen or something, it would be here included. So you define the pipeline. I'm going to run the cell here. So again, it's going to simply just write this in a config.yaml file. And once you have that, you are all good to go ahead and train the model. So here, I'm actually going to do so. So first of all, I'm going to load all these amazing files that I created. So to load the training data, I will simply call load data. And the file was called nlu.md. So you can see it works in a similar way as if you, for example, used sklearn to build a machine learning model and train. You pass all the files first. So then you can create the trainer, which will define the model. So trainer will use a configuration file. So I think it's just a dot config load. And I will load the configuration file because it defines the model. So config.yaml, and once all these things are ready, I can actually train the model by calling trainer method train, self-explanatory. And here I'm going to simply pass the training data in. And since I want to see the output of the model, what is happening, how it performs, I will also set verbose to true, which will simply print the training results. And the last thing is I can save the model somewhere on my machine. So I will just simply call interpreter, because that's how my model will be saved. And I will call a method called persist. And here I can just simply define where the model will be saved after the training. So I will create the directory called models, and I will save it in a NLU model directory. And I can also set the fixed model name, and that helps because if you want to make improvements and if you want to retrain the model, it's going to be saved in exact the same directory and exact the same name. If you wouldn't, then every single time you run this function here, here, Rasa NLU would generate a new model name with date and like timestamp for you to know when it was trained. So I will set fixed model name, which I will call current. Okay, let's try and see what happens. Okay, so you can see already, where is it? There are the summary of all the intents you had in your training data, entities, and so on. And then every single component that was included in the pipeline is trained one after another. So you can see it used tokenizer whitespace, then conditional random field, then the classifier, and why it failed. Oh, it should be trainer, yes. Sorry. Yeah. So hopefully it's not going to take long. Yeah, so and you can see it trains the model, and also since it's a very tiny little model, you can also get some, not too much, but some results of the training. So what is the loss, what is the accuracy, and then once the model is trained, is being saved in the directory where you specified. So the model is trained, great, time to actually test it and see how it performs. There are two ways how you can do that. One of them is just simply test it on user inputs. So here I'm going to use this pretty print function that I defined at the very beginning, and I will call interpreter parse method, and here I just can simply type in what a user could say. So let's try with very simple and safe option hello, and here you can see the results of the NLU model. So what it gives, the first thing is here, which is the most probable intent that was assigned to this user input. Here you can see the name of this intent was greet. You can also get the confidence, how confident your model was to make this prediction. Also, you can get the list of entities that were extracted, but since hello message doesn't have any entities, the model didn't find any. And then everything else that is here are the results of intent classification for all the other intents in the training data, and also you can see how confident the model was to make those predictions. I will try it for another one where I can actually show you how entity extraction looks like. So I will use this paper search. So I will say I would like to read a paper about, let's say, machine learning. Let's see if that works. Okay, so one thing is that it's not really in form. So this is where the model actually made a mistake. It should have predicted probably paper search. But again, it happened because I have a very tiny amount of training data. But the good thing that happened here is that we have an entity, machine learning, which is actually a type of paper that you could look for, and as you can see, it extracted the value of this entity. It assigned the entity label, which is paper type. Also, you get the confidence level, and also this start and end just simply corresponds to where in a sentence this entity is. Okay, so that is one of the ways to test your model. Again, you can spend more time playing around with this. But another way is to actually run some evaluation. And Rasa NLU comes with some evaluation scripts that you can run. So result of this evaluation here is going to be a confusion matrix for all intents that you have in your training data, and how confident, well, how good your model was in predicting those on the test data set. And again, it's super tiny training data that I used, so I'm pretty sure my model overfitted quite heavily, because you can see how perfect it is right here. I can see one mistake here actually, which is good. There should be more probably. So greet was confused with goodbye once. Kind of makes sense because, yeah, greet and goodbye, they examples of those intents have usually just one word, like hi or goodbye. So maybe it was a bit too confusing for the model to learn. But that would improve if you would add more possible examples. And then you can get as well intent prediction confidence distribution, which doesn't look very nice for some reason here. but basically it also gives you more information of how good your model was, how confident the model was in making predictions. And so if you see a lot of mistakes that your model does, the first thing that a developer should do is to go back to the training data, to the training examples, and see if there is anything in the intents, how intents are defined, what kind of examples are being provided, and maybe something actually adds more noise to the model rather than actually making it better. So, we have a question.
I noticed about your label, it's definitely a supervised learning.
Yeah.
Does it mean you have to enumerate all the possible combinations of labels in your training set to meet up with the natural language dialogues? Because I can imagine, for example, a firm, that label can get matched with all the other labels. Because I can say, okay, goodbye. Okay, I want to search for another paper or something. So it's almost like impossible to exhaust all the kind of combinations.
Yeah, but that's the main idea behind using real conversational data. So whenever you get a conversation that had something new, you would reuse that conversation and you would add this to your training data. And the main advantage behind, for example, rule-based approach when we are talking about dialogue management is that if you used rules, a developer would have to go through the entire architecture of the system and find where this new rule would be added. While in this type of approach, you would simply add this conversation into the training data as well as NLU and retrain the model, and that would pick up. But yeah, you would have to add combinations if there are more combinations that you would like to cover your model.
From a very naive idea, is it possible that you can just do all the binary classification and then eventually, because you will have a rank, and you will select, but you don't need to do the combination labels, but you have all the individual labels and have, for example, all the confidential level over 80%, then those two or those multiple labels are being matched with that circumstance. So do you think that would be a way to get rid of the, unlimited combination?
Yeah, well, it kind of works under the hood in a very similar way, because when you have multi-intent and when you have a single intent, especially when you have multi-intent, the tokens of this multi-intent are separated and each of them are being trained separately, but still for the model to learn that there are two meanings for one, at least for now, and at least how it works at Rasa, you would still have to include them combined in your training data example. But that's interesting, so maybe it's going to be something for the future to look into. Cool. Yeah, another question?
Curious how long this document looks like for a real application. How many lines of code have you guys experienced for building, like if you want a chatbot for credit card data? Like you have so many different people with so many different ways of saying hi. What do you typically see in your experience building chatbots for folks?
Yeah, so one thing is that we don't really build chatbots for companies, we just provide software, but based on use cases that I see developers have, it really depends on how many intents you would have, how many entities, how many actions. So the more you have, of course, the more training data you need, but for a big use case and something that runs in production, you would definitely need at least 100 or even more examples for each intent. But then again, the main idea, and it's one of the tips that I was about to share at the very end, is that the idea is that you build something simple, you give people an access to your application, people can start talking to it, and then you capture all conversations and then reuse them. So it's really not scalable approach at all for a developer to generate hundreds and hundreds of user inputs. It's really, really bad approach. I have some bad experience with that myself.
Is there any way that the core, the software can tell its model is producing a response that is always getting a confused or even a I don't understand back, and then mark that?
Yep. Yeah, so the way it works is that you actually can use those confidences that, for example, NLU model produces. The same is for Rasa core model. And then you can actually set the threshold. So if the prediction is below something like 0.2 or 1, then a chatbot should always say something or do something or hand over to a human. So that's...
Does it update its model?
Sorry, update what?
Does it fix itself? Does it remove that? Or does it make adjustments while it's running?
Yeah. Yes. Mm-hmm.
How do you go about handling different languages?
Oh, actually, I didn't mention this. So if you go pre-trained word vector way, then you are limited to those languages that have pre-trained word vectors. So for example, Spacey, they have language models for English, for I'm pretty sure German, Italian, French, so basically it's a variety of languages. But if you, for example, my native language is Lithuanian, and now there are some pre-trained word vectors with fast text, but before that there were no pre-trained word vectors. So this is where you would use this pipeline called and model called word embedding, because since it doesn't use any pre-trained word vectors, you can use it for any language that can be tokenized. So basically, it's language agnostic, and you can build a chatbot in any language. Yeah, a question there?
You talked about vectors and stuff. Can you point it at a dictionary or a thesaurus to try to recognize synonyms, or are you entirely dependent on training?
So speaking of synonyms, you can actually include that in your model. And you can also provide possible ways of, for example, if you have an entity in New York, you can have New York City, you can have NY, and the model will also learn that if it's something, one of those few possible ways of how a person could say the specific name of the city, then it would still extract this as an entity, city, or location. Yeah?
Apologies if this has already been discussed earlier, but can you just give a quick sense of what's going on under the hood in terms of, test sets and, I don't know, hyperparameters, anything that plays a role there?
So for test sets, so it works exactly the same as in any other machine learning problem. You would have some held out data and run predictions on that, and then see how good or bad the predictions were. In terms of parameter tuning, so you can definitely change epochs, how many epochs were used to train the model. You can also play around with different features. So for example, as I mentioned, sometimes n-grams or other specific text features are being included, so you can also play around with what helps to improve your model, what not.
Is there some sort of default configuration then?
Yeah, exactly. Okay. Can I actually, I'm a bit short on time, and I will move on to the next stage of dialogue management, and then I will definitely answer your question after, if that's okay. So please remember your question. Okay, the next stage is dialogue management. So a chatbot can understand what the user means, and now it's important to enable your assistant to respond, and respond well. So again, Rasa core, and why would you use Rasa core? So, as I mentioned already, state machines and rule-based approaches, they are actually really great approaches to start prototyping something, build something simple. But the challenge comes when you want to build something in production, and when things go big. This is where I have some experience as well, building chatbots in production. It really gets quite quickly to the stage where you, as a developer, spend way more time going through the architecture of your assistant, trying to debug the rules instead of actually improving your assistant. So machine learning, it takes a completely different approach than defining the rules and expecting your users to follow those rules. With machine learning, you gather conversations and then you model them to approximate to those conversations. Reinforcement learning is actually a really good approach when it comes to dialogues, and I think this is where it is going to get in the future. However, it's especially in NLP-related problems is a really difficult task still, because it's really hard to define good reward function. Also, you need a lot of training data, and people want to build something quickly. And with Rasa core, you can build something simple, and as I mentioned, give out to the users quite quickly with relatively small training data examples. As I mentioned, the main idea is, instead of writing more rules and building huge architectures like this, and I think this is the architecture of an assistant built with a state machine that can handle only just a few things well, and you can see already how big that is. So instead of writing more rules, it's probably better to actually look at how people talk to each other or talk to a chatbot and use that to model the conversations. So, dialogue management, how it works. First, the simple explanation. So, of course, an LU model plays an important part because it gives the meaning of what the user meant. So, intents and entities are being used in the model, and they are combined with the current state of the conversation, what the user basically asked. And also previous actions, so the history of the conversations also come into place. All of this is being used to predict the next action. What type of models you can use? You have a selection, a simple approach, SVM, but it's probably not going to use the history of the conversations. What is being implemented in Rasa by default is a recurrent neural network, because it's going to use what happened now, what happened beforehand, and use that to make predictions. So once the next action is predicted, again, the state is updated. Also, an assistant gives the response back to the user, and the cycle repeats. Whenever a user responds again, saying something, this is combined with this new updated state and used to make a prediction for the next action. So this is a simple explanation. Now let's dig a little deeper. So how it looks even more under the hood. So again, an LU model, intent classification and entity extraction results are being used. They are being fed to recurrent neural network. And not only that, but also if in previous actions an assistant made some API calls or extracted some important details that should have effect on how an assistant should respond in the next stage, those details are also being used. Another thing is that if you do actually want to add some rules or business logic to how your assistant responds, you can do that by adding action masks. So what it does, it simply limits possible actions that can be predicted by an assistant at specific stage on the conversations. So if you do that, then of course to follow the rules of probability theory, you have to renormalize them so that probabilities that are predicted would sum to 1. Just like in a previous slide you saw, the action is being predicted and the response is being made and passed to the user, and then again all these details are being reused for the next actions. Also, this cycle here, or prediction cycle, it doesn't mean that it has to repeat only once when the user says something. So it doesn't have to be one user input, one chatbot response. It can be one user input, 2 or 5 actions from a chatbot's end. So again, it depends on what kind of conversations you are going to model using Rasa core. So let's go back to the code and implement the dialogue management model. I have to go down. So again, since it's machine learning, the starting point is again data, and this is where you would reuse those conversations that your users would have with an assistant. The only thing again that has to be done is that these conversations have to be converted into Rasa format, and this format is called Rasa stories. A story is an actual conversation between a user and a bot. The only difference is that user inputs have to be converted into those intent labels and entity labels, while the responses of a chatbot has to be converted into action names. So I will quickly show an example how to do so. So let's say, again, I will use the same conversation I had before. So the conversation started with the user said, hi. So the intent of this input was greet. In Rasa story, user input would start with a star, and I would just simply pass this intent greet. A chatbot responded with, hey, I'm a paper search assistant, how can I help? This is where I have to assign action name to this response. Probably a good one could be utterance greet. Then a user said, I'm looking for interesting papers to read. So if I remember correctly, this intent was paper search. Then a chatbot asked, what type of papers are you interested in? So it could be utterance ask type, maybe. And then a user said about physics. So again, the intent of this was inform, and since I have an entity here which should have impact on what prediction of the action should be made, so I should provide this as well when converting into Rasa story. So an entity was called, I think, paper type, and I would provide the value, which here doesn't have any difference. What is going to matter, can't type anymore, is if this entity is provided or not in a user input, and so on. So basically, again, cutting this short, it's a very important step, so don't cut when you develop bots. But basically, you would go through a conversation like that and convert user inputs into intents and entities, and responses into action names. And again, the goal here, just like in NLU model, to get the data that is diverse, that covers different possible turns of the conversation, because again, you want to build a model that generalizes well. So if you will have even hundreds or thousands of stories like that, which will cover basically the same conversation over and over again, the model is not going to be good. So you have to gather diverse data or generate diverse data enough when you just start developing. Again, I'm going to do this quick cheat. I will use the file called stories.md that has, I think, just about 7 or 8 possible stories which represent the possible conversations that I would have with my assistant. So, for example, if I can show another one that is different. So this is super quick one. So a user said, hey, a chatbot responded with hi. Then a user asked for statistics papers, probably. A chatbot found one, asked if a user would like to read it. A user said no, that it was a horrible suggestion. And then a chatbot got mad and said, okay, then goodbye. So basically, again, you have to cover at least few possible turns in the conversation with those stories. So I'm going to just, again, run this cell and save this data. So the next step, once you have the data, again, the most important step covered, you have to define the domain. Domain basically defines the universe or environment where the chatbot will operate. So it means that a chatbot should know what kind of intents and entities it should expect to get from the user. So exactly the same ones you define in your training data. And also what kind of actions it should be ready to predict. So again, just exactly the same ones you defined in your stories using action labels that you came up with. And 2 additional things that I haven't mentioned yet. One of them is called slots. Slots work as placeholders for important details that an assistant should respond throughout the conversation, like from the very beginning until the end, or until a specific point where you would like your assistant to update specific value. So for example, right here, my chatbot will remember what kind of paper I asked throughout the entire conversation. Also, when it will get some details about the recommendation, it will remember what's the link of the paper that it found, who wrote the paper, and so on, so that when the user asks follow-up questions, the user wouldn't have to remind again, hey, I asked about this statistics paper, can you also tell me what is the author? A chatbot will remember that by itself. And another piece here is called templates. So here is where you can define how an assistant will respond once specific actions are predicted. As I mentioned, you have possible options here. This one is simple and quick. You simply can define how a user will respond. If you don't like this approach, you can use natural language generation to actually build a model to generate those responses for you. But here, basically, I'm defining that when action utterance greet is predicted, a chatbot will respond with, hey, I'm Paper Search Assistant, how can I help? If you want, you can, of course, define more than one possible way how a chatbot could respond, so then it's going to randomize a little and it's going to be more engaging and interesting chatbot to use. Okay, so this is domain. It defines the universe where a chatbot lives. And another thing that is not mandatory, but again, if you want to build an engaging chatbot, you would probably want to include some more complicated actions. So I showed you how you can define possible text responses, how a user could respond, but in some cases you would like to use those backend integrations. So if you want to, and I do so as well, because I will want my chatbot to actually literally look for a paper out in the web and suggest me something, I would like to implement an API call here. So those more complicated actions in Rasa are called custom actions, and a custom action is a class that consists of two functions. First one is very simple, which is called name. So it simply defines the name of this custom action, so that an assistant would know what kind of label should be assigned to this action. And once this action paper search label is going to be predicted, a chatbot will know that it has to run everything that is defined in this function run, and this is the body of this function, and here you write what the chatbot should do at this stage. So what I'm going to do here, I'm just going to retrieve details from what was the query from the user and use those details to implement the API call. So first thing that I will do is I will retrieve the paper type that the user would ask, and tracker in Rasa core is responsible for keeping track of all the slots that are being populated and kept. So I will call get slot method. So and I will also retrieve the slot which was paper type, so that an assistant would know what kind of paper it should look like, should look for. And here is just a very simple, I'm just making a request to look for a paper. I'm using here an API that is provided by one of the German universities, so it's basically a really nice library of scientific papers that you can play around. They have an API, so I decided to use this as an example here. So I'm simply using the paper type to get a paper suggestion, and I'm just simply taking one of the suggestions. I'm also reviewing some details about this paper, so what is the title, who are the authors of the paper, also the link to the paper that I could pass it to the user, and the last stage here is to simply pass them those details to the user in a human language. I will call dispatcher, which is responsible in Rasa core to dispatch the messages back to the user. So dispatcher, and it has a method called utter message, which sends messages back to the user. And here then I can define what kind of message will be sent back to the user. Again, it's not mandatory. If you have some specific action which doesn't really have a specific text response, it can be something else. It can be a picture that your assistant would send, or a video, or it really depends on your use case. But here I will define a message that will say, I found a paper called, and I will simply pass the paper title just like that. And the very last line here is I'm simply setting the slots for those details that were returned after making this API call. So the title, the authors, the link, so that my chatbot would remember those details, and again, that a user wouldn't have to remind the chatbot every single time what kind of paper it looked for. Okay. I guess it's fine. If not, I will get some errors, but we will see. Here, where I'm going to use this quick GraphViz example. So one of the ways how you can debug your stories and see if actually it makes sense how your model is going to model them or not is to actually visualize them. Let's see if that's going to work for me. Okay, it did. So what it does, it simply visualizes the path that is covered by the stories you have in your training data. So for example, here you can see the conversations would start with greet, and then the flow of the conversation would be divided into two possible paths. One is when a user immediately asks for paper search and doesn't define what kind of type of paper they are looking for. Another one when the user immediately provides all these details and so on. And how it's useful is that you can see what kind of conversational turns are going to be covered. And again, this is where a developer can look into it and see if maybe something is too complicated, maybe something can be removed, and maybe something is just, again, adding way more noise into your model, and how the conversations are going to be modeled, then it actually helps. So again, if you have more time to play around with this, definitely spend more time looking into it. But I will move on to the actually training the bot. So I will run the cell here. Very similar process. I'm loading the files that I defined it previously, which is my stories data for training and domain. I also define policies, so what kind of models are going to be used. For example, Keras policies, this LSTM model that includes current state of the conversation and previous states. And here you can also see just a very few hyperparameters which you can tune and play around with. So actually just one here, how many epochs you're going to use for training, but there are a lot more of things you can customize and change and test. And then you can see the architecture of the model that was being used, and also for each epoch, what was the loss, what is the accuracy, and so on, and inspect your model like that. I'm not going to spend too much time here, but again, if you are developing your bot, it's something you would look into in more detail. But now I'm actually going to show you how my bot works, because I spent quite a long time building it, so let's see. So the one thing before I actually load the model, the agent, and test it out, I have to define the server for custom actions, because in Rasa core, custom actions run on a completely different server than your bot and all the models. That helps in a way that you can make changes to both separately, and you don't have to restart your entire assistant whenever you make a change to, I don't know, API call or database connection or something like that. So since it needs to run on a separate server, I'm going to do some Jupyter magic. I will actually have a command line inside my Jupyter and start the action server just by running this command, which will start the server, and it registers the custom action that I created, which was called action paper search. Now it's running, it's ready to run this custom action if it is predicted, and I can actually go ahead and load my model and see if it's going to talk to me. So here, important things are just what I have to do is I have to load my NLU model that I trained previously. I have to load the dialog management model, which I trained previously, and that's it. Everything else here is just Jupyter configurations to have this little chat box inside my Jupyter notebook. So let's see, what can it do for me? So we'll start the conversation with hello, and my chatbot responded, hey, I'm a paper search assistant, how can I help? I will say, I'm looking for papers about, I will call chatbots. So I found a paper called Response Selection with Topic Clues for Retrieval-Based Chatbots. That probably is about chatbots. And would you like to read this paper? And I can send you a link. So I will try to do this multi-intent example. So I'll say yes. Can you also tell me who are the authors? Let's see what happens. Oh, it worked. I'm a bit surprised because we have a really small amount of data. So it sent me a link. I can actually maybe try and open it to see if that actually gave me what I asked. So yeah, response selection for topic clues. Yeah, so if you want to, I think there is a PDF reader where you can actually read the paper. And it sent me a list of authors, which is one author. Okay, so then I will say thanks, and that's all. Enjoy your reading. So that is just one example. Again, please play around with it, break it, fix it, improve it, and see how that works. I have just 15 minutes left. There is one more thing that I really wanted to show you. I will skip this part. Evaluation is exactly the same as in NLU. You can run evaluation script and get confusion matrix for action prediction. But what I wanted to show you, which is actually my next step, is, I will quickly go back to my slides, which is closing the feedback loop. So something that I mentioned, that an assistant has to be able to learn from user feedback, additional details that a user provides, and this is what we call interactive learning in Rasa core. So the way it works is that when an assistant responds to the user input, if a user sees that actually this response was incorrect, a user can tell this to a bot, you did a mistake, and then a chatbot picks up those details and learns from it live, basically. And then it corrects itself and gives the better response. So quickly back to my code. So that's the very last step. This is not included in Google Colab because it needs to run on a CMD in a command line. But it's included here. So I will just simply run this function here. What it's going to do is going to quickly retrain my Rasa core model. It's not necessary. If you want to, you can just simply load your previously trained model. And it's going to launch the model in an interactive learning session. And the interactive learning session means that instead of immediately running the predicted action, a chatbot will tell me what it thinks it should respond with, also how it understood my input, and then ask if that's correct or not, and then a user or developer can provide the feedback and improve the model. So, but everything happens in a way that I actually just talk to a bot and just get those outputs. So I will start with a similar conversation. I'll say hello. And here an assistant says, is the NLU classification for hello with the intent greet is correct? So here I can already tell if the intent classification was correct or not. So in this case it was correct, so I would say yes. And then it provides the chat history with as well confidence levels for predictions and so on. And then it goes with the actions as well. So now the chatbot wants to run utterance greet. Is it correct or not? So a chatbot wants to respond with a hello message back. So that is also seems like a proper behavior for a chatbot when someone says hello. So that is correct. And then a chatbot executes this action, and then it keeps this information when updating the model. Now, because I'm short on time, I would just make up the situation when the prediction isn't correct. So let's say now my bot wants to run action listen, which means that it wants to listen for next input from a user, and let's say it's not correct. It is, but let's say it's not. So then I would say no, that's not correct. And then my assistant gives me the model gives me all predicted actions with confidences. Here it was super confident that it actually should listen for the next user input. But if it was something else, and if I would want to add this functionality to my chatbot and train a different conversation flow, I could just simply choose something else. I don't know, say, ask, look for the authors, and so on. and then it updates by itself. And then another good thing about interactive learning is that it's a good way as well to generate some training data. So when you talk to a bot in this interactive learning session, not only the model is updated live, but also you can export the conversations you had with an assistant already in a Rasa format. So this is where I mentioned that it's actually also a good way to get started when you have no training data. Simply talk to your bot like this, teach new features, add new labels, intents, entities, and so on, and you can extract all this data just like that. You can export and save the data. So super quick, you can definitely play more around with it, and also since there were some new features added to Rasa Core, if you will try the latest version of Rasa Core, you will see there are some cool visualizations that come with this one, with this feature, so give it a try. But right now I will actually go back to my slides and I will just share some final thoughts. So the main idea is that, again, it's important to not only collect good data, build a model that scales, that behaves well, but also include the user feedback and close the feedback loop when a user can give feedback and improve the model as the conversation goes. However, even though it might look like it's easy, you can just go ahead and build all chatbots in the world, it's actually NLP is far from being a solved issue, and there are so many challenges and so many limitations yet still out there. And if you are interested in this field, there are just a very few suggestions what you could look into and work on. So for example, one of them is combination of dialogue models. So it's relatively easy, I would say, to build a model that performs well in a specific domain, for example, hotel search or restaurant search. But the challenge comes when you want to build a chatbot that can kind of do it all or do more than one thing well. So this is where Rasa also is working on research on that end a lot, and we released a paper quite recently. So hopefully the next time I give a talk about it, I will share some news on that end. Negation is also a really big issue still. How do you train the model that understands negation and does it well? And Rasa is constantly working on improving the models, and if you want to, you can definitely contribute to that as well, because again, it's open source. So these are just take-home thoughts. Apart from mentioning again that machine learning is in production scales better than rule-based approaches, I also want to mention that, again, it's not like rule-based approaches or state machines are like the worst and you should never use them. Actually, it does sometimes make a lot more sense to combine both and use rules and some business logic alongside the machine learning, and it actually works a lot better than just always relying on machine learning only. It's really important to be mindful and understand the problem you're dealing with and what you want to build, and build your solutions based on that. And to finish, my contact details are here. You can send me emails, can find me on Twitter as well. And again, since Rasa is open source and something that I focus on as a developer advocate at Rasa, we are building open source community around Rasa. We have really nice bunch of contributors, over 100 contributors, no, actually 150 contributors who contributed code and who does an amazing job helping others to get started with Rasa and helping us to push the limits of our software and the field. So if you're interested, do check out our community, join it, and let's work on this exciting field together. So thank you. And now I think I have some few minutes left to answer some questions, so please feel free. You had a question, yeah.
The models that you used here were part of the Rasa library, but if I wanted to use something like, let's say, out of scikit-learn, there's easy to integrate that into your framework.
Yeah, it's pretty easy. So if you remember when I showed the pipeline, when you configure the pipeline, instead of using the label of the component that is inbuilt in Rasa, you would use your own reference to your own model somewhere in a specific file or somewhere else.
So I guess like the Rasa model behaves similarly to like the scikit-learn model in Keras.
Yeah, but again, you can integrate them to work together, or you can, not use something. It's based on my own experience working with Rasa is probably the library that I had the most fun with when it comes to customization, because it's really easy to add new things, to remove something. So yeah, it's really open to new things. Yeah.
Okay, yeah. So basically, you had mentioned it sort of relies on a recurrent neural network, at least the default iteration.
Yeah.
So I guess it would strike me then that it could potentially, the retraining that it goes through, it could be quite sensitive to your choice of activation functions within your node, so to speak. I guess, have you found like a specific set that tends to, not maybe overcorrect too much, undercorrect anytime there's an error? Like, can you speak a little bit to that?
Yeah, so again, since Rasa Core comes with hyperparameters that are set, so there is a default set of parameters. You can find them all in the code because, again, everything is public and open source. You can look into what kind of set of parameters it uses. But also, as I showed, it really depends on your problem, the field, the domain you are building your assistant in, and how much data you have. So this is where you can see that if actually the default values of hyperparameters are not really working well, you can actually tune them yourself and set different values of hyperparameters. For intent classification and entity extraction, since it uses SVM, it also runs grid search, and it looks for best hyperparameters every single time. But again, it's something you can also change depending on how you want the models to behave. It was a question here before.
Actually, you answered my other question, whether or not we have the very best models already included.
Yeah.
No secret ones for services to, for purchase or things.
No. Again, everything is open source, so you see everything, and there are default models, there are default values that, based on our research and testing, performs best. But again, you can see everything and change whatever you want.
Defaults that you mentioned, and have those stayed pretty stable even when you made changes? When you've changed your trainings, when you run these 300 epochs is about right. You're not overtraining. Is that?
No, well, that is a parameter that is super easy to tune, and this is something that we actually encourage people to think about when, depending on how much data they have. But it's more about like how many layers are being used in the neural network, and this is where we do provide defaults that works pretty well on majority of data sets that we tested. But again, if it's something super specific, it might not work for your specific case, and you might want to look into it and make changes.
My question is, how you organize the answer fetch from somewhere, probably Google results, and then organize the answer as a natural language expression and provide feedback to the customer. If you get the paper title and how you organize it as a sentence, is it with some algorithm that you guys have already tested?
Oh, you mean how to use that to generate training examples in a way?
Right.
Yeah.
Roll back a little bit. How you get those answer keywords like paper name, author name, and also how to organize that as a natural language?
Yeah. So again, it's something that really depends on developer and how they want to build. Again, because we don't build chatbots for other developers or companies, but there are some tools. One of them is called Chatito, which is quite popular. So it's you can, for example, do some web scraping and fetch possible, papers that people might want to read, and then you can define that those specific entities should be included, and then you can define the structure of the sentence that you would like your training examples to have, and then it generates with a randomization generates a lot of possible ways of how a user could ask for different papers and so on. Another way is again just by just looking at what kind of things people ask. So it's something where it's a little easier for customer services and companies that actually has some data, maybe not specifically in a nice conversational format, but something that they can actually take, understand what kind of things people would ask, and then reuse those details.
Could you spell the library name again? Sorry.
Yeah, it's Petraitytė, so it's, yeah. Let me see if I can find. Yeah, this one. Yep, here.
Much appreciated.
No worries. Yeah, okay, I see one question there and then here, okay?
I'm going to cheat. I have a two-part, sorry. One of the things you mentioned when you were going through your slides was the challenge in coming up with training examples. In the notebook that you went through, you were essentially annotating the intents as you were giving the training examples. As the data scales, or let's say you have a state machine chatbot that you're translating into something more natural, we have a lot of training data which need to be annotated. I know you guys have a solution called Prodigy for that. Can you touch on maybe what the future is for that in terms of multiple people in the team annotating it? And my second question, are there any best practices for actually deploying this in production?
Yeah, so on a data point of view, yeah, that's actually a big thing when it comes to developing something, and especially when companies, as you mentioned, have already a lot of conversational data. I do see this in a lot of companies becoming a future for people to actually being hired for those type of positions, to actually go through not necessarily only conversational data, but when it comes to any other machine learning application, to actually do data annotation. Yeah, but right now the best approach, as I mentioned, is to actually do annotation for at least a subset and then give it to the users, and then reuse what is produced by Rasa as you talk to your bot. And for deployment part, so based on what we see when it comes to big companies, how they deploy is Docker is probably the best way to actually package it easily and run it in production, because also Rasa comes with Docker images for everything. It's usually right now a go-to solution when it comes to deploying. Yes?
Kind of a question about chatbots in general, but how do they deal with sarcasm?
Yeah, interesting.
That wasn't sarcasm.
No. Yeah, it's also one of those tough problems in NLP. I know some people working on sarcasm classification and identification, but it's basically another model that you would build. I'm actually maybe can touch this on just in general how we would add additional component to the model. So a really common request from developers is like, how do you add, for example, sentiment analysis to your bot, or sarcasm identification, and then use the results of the model to adjust your bot. So you can also do that, and you would get either label how sarcastic it is or not. But again, it's not. It kind of falls into the chatbot field, but over there you would build a different model to extract features that will identify what is sarcasm, what is not. Yeah. Any more questions? Okay, if not, so then thank you very much for coming and staying. And I will be here tomorrow, so if you have more questions or something that you would like to talk about, also just catch me. I also have some cool Rasa stickers, so it's really worth speaking to me. Thank you.